Welcome to This Explainer. I'm absolutely thrilled you're here today because we're going to unpack a paper that fundamentally changes how we look at the financial world. We're diving into a brilliant new academic framework called Graph LLM. Now, we hear a lot about AI these days, I know, but today we're going to look at how artificial intelligence is practically turning bank supervision into a high-stakes detective investigation. We're talking about tracking down the actual ground truth reality behind multi-billion-dollar corporate claims.
So, I want to start by asking you this. How do we actually know if our major banks are prepared for climate change? And we aren't just talking about abstract environmental science here. No, we're talking about the real-world stakes for the global economy, your pension, and, well, your own wallet. Because if major banks misjudge these massive systemic risks, the ripple effects, they're devastating. I mean, anyone can release a flashy sustainability report, right? But how do regulators mathematically verify those claims?
To answer that, here's our roadmap for today. We'll quickly cover the climate risk problem, why current methods fail, building the knowledge graph, the SAR framework, the 6 addressing dimensions, and finally, why traceability matters. Let's jump right in.
All right, Section 1, the climate risk problem.
Okay, let's break this down. Climate risk isn't just one giant, vague cloud. According to the foundational literature, bank supervisors actually have to track 3 very distinct channels. First up is transition risk. Think of this as a bank's exposure to massive market or policy shifts, like the sudden move to a low-carbon economy. Second is physical risk. These are the actual acute and chronic hazards, literally things like floods or wildfires damaging physical assets. And third is liability risk, exposure to lawsuits and litigation coming from sustainability omissions or, greenwashing. Now here's the massive challenge. Bank detectives have to evaluate all 3 of these incredibly different channels under one common analytical frame. They can't just awkwardly stitch them together after the fact.
Moving on to Section 2, why current methods fail. Historically, the financial sector has relied heavily on things like composite ESG scores. But as the source paper points out, ESG scores are, well, they're opaque. They really just measure a firm's stated posture, which is basically whatever their PR department says. And different rating agencies give completely divergent scores. It's a total black box. But the Graph LLM method, it is entirely traceable. It literally brings the receipts to prove what's actually happening at the predicate level of evidence. It doesn't just grade a bank's vibe, it computes the literal residual gap in their risk management.
Which brings us to Section 3, building the knowledge graph.
We start building this giant evidence board with our very first and, honestly, incredibly messy input, the firm's own disclosures. These are the annual reports, the climate position statements, and the transition plans. In our detective analogy, this is where the bank states their alibi. It's essentially them saying, hey, here's what we're doing, and here's why everything is totally fine. But as we all know, you can't just take a suspect's word for it.
So we add the second vital input to the board. The Graph LLM model ingests massive external corpora. We're talking about news articles, court records, and regulator letters. This acts as the rigorous fact-checking layer, because if the bank says they have 0 liability risks, but court filings show pending greenwashing litigation, boom, this layer catches that glaring discrepancy immediately.
And then we layer on the hard evidence, structured data sets. This includes regulatory registers, hazard rasters, which are basically geographical data maps showing physical world realities like flood zones, and massive transaction databases. This gives our investigators the cold, hard numbers that absolutely cannot be spun by a marketing department.
Let's see how this all comes together. You've got all these disparate clues, right? Text, spreadsheets, geographic maps. Well, the absolute genius of Graph LLM is that it uses a fine-tuned large language model to act as that famous red string on a detective's corkboard. It ingests all of these different modalities and perfectly connects them into a singular, computable, typed graph of factual claims. It maps out exactly how an asset in a flood zone connects to a specific bank loan and whether the bank's annual report even bothers to mention it.
That brings us to Section 4, the SAR framework explained.
Now, SAR stands for Source, Addressed, and Remaining. Please memorize that acronym, because it is just brilliant in its simplicity. Instead of just handing a bank an arbitrary letter grade, the SAR framework decomposes supervision into 3 completely computable buckets: the source of the potential risk, the addressed actions the firm has actually taken, and the remaining residual gap. The math here is incredibly powerful. You take the total source bucket. That's all the factual exposures the bank faces in reality. Then you subtract the addressed bucket, which are the verifiable responses the firm has legitimately implemented. What you are left with is the remaining risk.
That remaining piece, that is the exact vulnerability the bank is currently exposed to. It's the missing piece of the puzzle that regulators desperately need to see.
Section 5. The 6 addressing dimensions.
To do this subtraction accurately, Graph LLM acts as a ruthless academic checklist, evaluating 6 strict dimensions. Number 1, identification. Did they actually name the risk? 2, governance. Is there a board-level body overseeing it? 3, measurement. Is there a defined metric with a reported value? 4, target. Is there a numeric target with a baseline year? 5, assurance. Is this data externally assured? And 6, disclosure quality. Is the evidence sufficiently specific? This means a firm gets 0 credit for simply tossing the phrase climate change into a glossy brochure. To move a risk into the addressed bucket, they must mathematically prove they have the governance and targets to handle it across all 6 of these dimensions.
And finally, Section 6. Why traceability matters. This is the ultimate output of the entire system. When the model spits out that remaining bucket, it isn't some arbitrary score of 72 out of 100. No, it's a ranked list of highly specific graph fragments. And the best part? It comes with complete provenance. Every single missing piece of risk points directly back to a specific document, a specific paragraph, or specific dataset row. If the model says a bank is exposed to a physical flood risk in a commercial real estate portfolio, it gives you the exact regulatory hazard map and the exact paragraph in the bank's filing that failed to address it. It is literally the ultimate receipt.
The authors of the paper honestly say it best. Graph LLM, quote, recasts climate risk measurement as a residual computation rather than a parallel scoring exercise. We are moving completely out of the era of just grading a bank's PR posture. We're entering an era of computing their actual verifiable vulnerabilities using hard data. It's a total paradigm shift for financial accountability. So, I want to leave you with this final provocative thought. If a tool like Graph LLM became the standard, and every single corporate claim required a verifiable, mathematically computed receipt, how would our global financial system transform? We'd essentially be eliminating the shadows where systemic risk likes to hide. I highly encourage you to keep exploring this fascinating intersection of AI, graph theory, and finance. Thank you so much for joining me on this explainer, and keep learning.